Today we're going to solve a system of equations, and in this case we're going to find where these two lines intersect, the point of intersection, which is important because if the directions say find the point of intersection, we're going to want our final answer to be a coordinate point, which I'll get to here in a second. Now in this first example, I have both equations that are equal to y, and if you were in our textbook right now, it would say use the equal values theorem because we have two equations, both equal to the same letter, then they're equal to one another. However, I'm going to use a modified version of that called substitution, and I'll do three versions of substitution right now. In this first one, I need to take one of these equations. Because they're both equal to y, I could choose either one. And I'm going to take this top guy up here, which is 4x plus 11, which is equal to y, and I'm literally going to replace it with the y in the second equation. So I'm going to put 4x plus 11 in place of that y, or substituting it for that y. So if I rewrite now the second equation without that y, but 4x in its place, plus 11, I end up with this equation. And this equation, hopefully, is very friendly to solve. We've been solving this for months. So I'm going to move this 3x over to the other side by adding it. I'm going to move the 11 over by subtracting it. And then a quick little division here at the end to solve for my x value. And I get -2. So at this point, I'm about halfway done. I have to find the point of intersection, and we have half of that point. We have the x value, and we all know x values get written first in a coordinate point, but I need that y value. At this point, we need to take our x value and plug it back into one of the equations up here that we started with, and you get to choose the one that you want. Choose the easiest one first, and then we will try the harder one afterwards to check our answer. But I'm just going to use that top equation up there. So I'm going to take my x value of -2, and I'm going to put it right into that x value in that top equation. And that will allow me to solve for y, hopefully, fairly quickly. So there's -2 put into that x value. At this point, we can solve this for y and end up getting the y value 3. And that y value finishes my coordinate point, the point of intersection where those two lines intersect. I'm going to box that. However, to be cautious, and this is kind of a cool thing that you all should do, to be cautious, we need to check our answer. So I'm going to take the x value that we originally got, -2, and I'm going to place it into the second equation, the one that I thought was harder, just to see if we get the same answer that we got with the top equation. So, rewriting the second equation, but putting -2 in for the x value, I end up with this equation. And let's see what we get. -3 times -2 is +6, and 6 minus that 3 again gets us 3. Checked. We know we got it right because we get 3 when we plug that -2 into both equations. So that is the point of intersection for those two lines. Here's the second equation, a little bit harder, a little more challenging. You'll notice that it doesn't have both equations equal to the same letter, so we're not going to use the equal values theorem. We're going to use substitution right now. And on this example, I do have one equation that's equal to a single letter, and that's a good thing. That tells you that substitution is what you're going to want to use. So because this top equation is equal to x, I'm going to circle this part. This is just a visual aid, and let you know that that part that I circled, which is equal to x, is going to replace x in the second equation. So I'm going to put it right there. I'm just going to point to where it's going. That x is going to be replaced with 4y minus 1. So we're going to rewrite this second equation. And when I get to the x, I'm going to stop and put the 4y minus 1 in its place. Now what's important here is that you have parentheses, because that 3 is going to need to be distributed. So what you replace should always use parentheses to be careful. All right, so I have substituted. I took the second equation and I replaced x with what x is equal to create an equation that just has one variable in it. So at this point we can solve. First we would distribute. And I like to combine like terms, so 14y's And I'll move that 3 over by adding 3 to both sides. And look at how friendly that's going to turn out when you divide both sides by 14. We get 1. So remember, this is half of a coordinate point. If the directions are to find the point of intersection, we're halfway home. So I'm going to write a coordinate point here and be very careful. We just found a y value to be 1, and y values, we should know, are written second. So we're going to put the 1 right there. So now we need to find x. So we take our 1 that we think is part of the answer. We go back up to the top 2 equations and we decide which one of those is easiest to plug into to help us solve for x. And it's going to be that top one. Hopefully you see that. So I'm going to put 1 in for that y, rewrite that equation, x equals 4 times 1 minus 1. So that's that top equation with 1 replacing y. And if we solve this fairly quickly, we get the x value of 3. Now, because I wrote in pen, and just in case, instead of putting that in my answer, I'm going to go check my work right now. So I'm going to take my answers, x equals 3 and y equals 1, and put them into the second equation and see if we get 11. So y we got to be 1, so I'm putting 1 in for that y. And x we just said was 3, putting 3 in for that x. And we're going to see what that equals, and it needs to equal 11. 2 plus 9. Yep, that equals 11. We're there. We got the right answer. So the x value 3 goes into my coordinate point, and that is the point of intersection for those two lines, 3, 1. The last type I want to do here, you'll notice, doesn't have any of the equations solved for a single letter. But you might spy something that you recognize can be helpful. The fact that that 3, and that 6, and that 15 are all divisible by 3, we can turn this top equation into an equation that is equal to a single letter by simply dividing everything up there by 3. So if I divide that top equation by 3, I divide all the parts here by 3, which you do to one side, you do to the other, and you'll notice I end up with a new top equation. That's y equals 2x minus 5. Much friendlier to work with. This will allow me to use substitution. So we had to change one of the equations. That doesn't happen often, but when you spy something that's that friendly, you might like what happens. So this 2x minus 5 is equal to y, and it's going to replace the y in the second equation. Make sure you use parentheses when you get there, which we're at right now. Come on, focus. And again, we have an equation here that just contains x's. So I'm going to distribute. Combine like terms. Get that variable by himself by adding 20 to both sides. And the last step would be to divide by 5. And I get x equals 7. I didn't show my work there, so hopefully Mr. Powers doesn't get mad at me because he loves showing his work. So we have an x value of 7, so I'm going to write that as half of our answer. The 7 that goes in for the x value, and now we're going to go find the y value. Now, I told you to go back to the 2 original equations, which you certainly can, because you never know if you did something wrong, but I'm going to trust the fact that this is right. And then we're going to check to make sure it's right by checking into the other equation. But I'm going to put my 7 in for this x value. Y equals 2 times 7 minus 5. And you'll notice we get a y value that hopefully is right, 9. But at this point, we should take our x value 7 and our y value 9 and plug them into the bottom equation, the one we haven't used at all, and see if we get the right answer. So I'm going to rewrite that. 15 equals, when I get to y, I'm going to replace y with 9. I'm going to replace x with 7. And we're going to see if that does, in fact, equal 15. 4 times 9, 36. 3 times 7 is 21. And I get 15. And it was supposed to equal 15. So it does check. Works perfectly. So I'm going to write the rest of my coordinate point, putting the y value of 9. Box that. There is the point of intersection.